welcome to a session of the technical workshop stream 2B on initial airworthiness approach for unmanned aircraft system. Thanks for showing up despite the confusion with the locations and the late Friday afternoon starting at 4 o'clock. So it really demonstrates that you are motivated to learn about what we are doing. And we will try to provide you with the best information we can. Practical information, we have Slido. I hope it's working. We had some difficulties in the session before. Please join the discussion. But of course, it's a small audience here, so we can also use just speak up. We can have a lively discussion. So the crew, my colleague Antonio Marchetto, ARPA's technologies expert. He is in my team working in the certification directorate with years of experience in the industry. Myself, Stefan, RONIG, I'm head of section for certification of light unmanned aircraft, but also light manned aircraft, balloons and airships. So a lot of interesting aircraft categories which require a lot of creativity when certifying them. We start with a few slides to introduce the initial airworthiness approach for unmanned aircraft system that we have. But this is more to start, to open the discussion and to have an interactive session. So the message is we have only 1 hour or up to 5 o'clock, but we should have some time for discussion and for interactivity. Just a very brief reminder, probably everybody has seen this illustration. It's the operation-centric approach we follow in Europe since a while with 3 categories of operation: open, specific, and certified category. And we want to talk about certification, which is mainly for the certified category, and in some areas of the specific category when this is requiring an EASA approval for the aircraft. So in general, certified category risk is similar as for manned navigation. There will be a certification of the UAS, and the operator and the pilot will be licensed when there's a pilot. So the aircraft, the unmanned aircraft, we're talking about unmanned aircraft system. Let's start with the aircraft. The unmanned aircraft will be subject to certification in accordance with Part 21, which is the regulation we have containing the procedures and processes for initial airworthiness certification, design and production. And the design of the aircraft, the unmanned aircraft, will be approved by issuing a type certificate or a restricted type certificate. Design and production will be performed in accordance with Part 21, which we have a process in place, a rulemaking task to amend the regulation because there are some areas that require adaptation. And after type certification of the type, the model of the unmanned aircraft, the individual aircraft that is produced following Part 21, produced in accordance with the requirements of an approved production organization, this will receive a certificate of airworthiness. And also maintenance is following the traditional regime. So we have maintenance requirements. In Part M, we have an organization performing oversight of the maintenance, and we have licensed staff in accordance with Part 66. The other element of the UAS is this equipment on the ground to control the aircraft. We use the term control unit, CU. The control unit will be specified as part of the unmanned aircraft type design, and it may receive another type of certificate, for example, in ETSO approval. We are working on this concept for the moment, so we might use different terminology, but the idea is to have as the control unit is heavily linked to the design of the aircraft, it's required for safe operation that it will be specified as part of the aircraft type design. But there is the option to have an individual approval, like an equipment approval, or more like a modular equipment approval, which will be issued by the agency. We are using the ICAO ARPAS layer concept. I have a slide on that. So ICAO started to work on the interaction between design, production, conformity, and of what's called RPS in the ICAO system, remote pilot station. And we will use the concept we call the station control unit, as it might also control several aircraft at the same time. So we have a wider scope on that compared to ICAO. Therefore, we avoid the term remote pilot station. But the concept itself is taken from ICAO. The independent approval in accordance with CTSO for the station or for the control unit or components of the station of the control unit is optional. And production of the core layer elements will be done in accordance also with Part 21, with a conformity statement in accordance with Part 21. The initial installation of the control unit will be performed under the responsibility of the control unit operator approval holder, following the approved installation instruction. I have a slide that goes a bit more into detail. It's complex system, and this is a problem we are faced when having now not only an aircraft but also equipment on the ground which might be linked to one aircraft at one moment in time, but it also changing from aircraft to aircraft. It might operate multiple aircraft maybe at the same time. So we needed to create a system that's flexible to be able to respond to all these operational needs, but of course ensuring safety. The maintenance and oversight of the control unit will also be under the control unit approval holder. So this is an entity that might have an independent operator approval or is done under the main operator approval. So now we issued two certificates. It's similar to design and production, but it's part of the operator requirements that define all the procedures that need to be followed by these control unit operator holder, approval holder, like maintenance of staff, like requirements to manage the continued oversight of the control unit, like managing the configuration of the control unit, but starting also already with the initial installation. This is a slide illustrating the ICAO ARPAS layer concept. We have a core layer which includes all elements and equipment essential for the crew to operate the unmanned aircraft. So on this slide you find ICAO terminology, sorry to confuse. We have the intermediate layer, where we have all assets, equipment and resources required to support the operation, to provide interface between the core and external layers, and to provide protection from undesired input such as hacking, power failures, EMI, etc. And we have the so-called outer world layer, the external layer, which is the commercial and public infrastructure, external networks, but also it could be service provider, C-tooling service provider. And the difficulty for the control unit is that it was in the past seen as a component of an aircraft, but we see more and more that in reality the aircraft is operated in a system of systems, and the control unit on the ground is one system, and it's connected to external networks, and not all the details can be defined by the manufacturer of the aircraft or the design organization of the aircraft. There will be elements and details that need to be defined when the operator or the control unit approval holder is installing this equipment into a building and starts to prepares it for operation. So of course, one of the essential activities before starting to operate then an unmanned aircraft with a new control unit is the initial installation, which could be seen as equivalent to a production, to a final assembly of a control unit. And the control unit is proposed to be released after the control unit approval holder ensures that it's installed in accordance with the installation instructions. All tests and verifications have been performed, and everything is done in accordance with installation manual, which is all the data that's provided by the design organization of the unmanned aircraft, or together with the equivalent data that's coming from the EASA approval holder. The conformity of the layers will have to be determined and confirmed in accordance with the specification of the type design. So we might have equipment, the core layer equipment, which could be black boxes coming from the manufacturer with a Form 1, which is providing the essential functionalities, the systems, flight management system on the ground, core elements like for the pilot interface. But there could be other elements that are specified to a lower level of conformity. So when there is a lighting system in a control station, this might be specified in accordance with an industry standard, which is applicable in the country where the station is or the control unit is installed. And then it's the conformity could be done by the operator installing the light bulbs and similar equipment. So there will be a strong link between the aircraft design approval holder defining the essential information, the core layer. In detail, a production organization will produce the critical parts, the core layer elements in accordance with traditional systems, but then this is handed over to the operator, who is responsible to install it properly and to maintain it properly. Another illustration to show the dependencies. We have here on the top level the stream that's focused on the aircraft. We have the unmanned aircraft, and you see from the top left to the right the activities, the operation, the continued airworthiness management, the maintenance, and the maintenance training and qualification, and the maintenance of components. And you see there the usual terminology of the organization that are involved in these activities. So we have an AOC holder, we have a CAMO, we have a maintenance organization, a 145 organization, and we have a maintenance training organization that ensure that the staff is qualified in accordance with the requirements. And we have component maintenance organization that is responsible to maintain components of the aircraft. On the lower end, we have the stream for the it's not updated, the remote pilot station or the control unit. The control unit is not registered like an aircraft, so it has not a call sign like an aircraft. It has no own CFA. And then you see the long box across all the domains that we have separated for the aircraft. So we have the AOC holder or the CU approval holder being responsible for all these streams. So being responsible for the operation of the station, for the continued airworthiness management, for the maintenance, but also to ensure that the staff is adequately trained. And in the blue boxes, you see the relevant regulation that need to be adapted or that need to be drafted to ensure that the adequate competence and the adequate procedures are available. So these control unit approval holder will have to follow requirements that are quite similar to Part M for the aircraft. So he needs to have the competence to do maintenance. On the core layer, he needs to have the competence, the competence to, or the procedures to train staff to ensure that the staff is adequately trained. It's not intended to come up with a maintenance license for the station. There we take or take elements we have also for this competency of staff that we have in the ATM environment, where we have different layers of competence, and the organization can develop a training program to ensure that the staff is adequately trained, which could be heavily based on the input coming from the designer, from the manufacturer. So it might be needed to perform training, maybe at the manufacturer location, to ensure that you are able to install an installation or an S control unit, or to maintain it. But we expect that there are frequent activities that need to be performed close to or by the approval holder, like software updates, like reconfigurations, like troubleshooting, so that the operator, the control unit staff, needs to be competent to deal with this more or less on a daily basis, that it's not adequate to contract this to a 145 organization, which might be located somewhere else, which is not permanently available. It's probably challenging to see this in a few minutes explained. It's a when you see it the first time, it's a complex concept, but it's flexible to take care for different levels of autonomy, for different levels of interaction between the station or the control unit and the aircraft, to be adaptable to multiple operational concepts: one aircraft and one station, one aircraft, multiple stations, multiple aircraft, multiple stations, different aircraft types, one station, which could be questions: why do we need all these? Most manufacturers at the moment, they have one aircraft and one station. But even today, the operational life of one control unit, at least for large drones, is not directly linked to the operational life of an aircraft. It might be released to service at a different time. You change it, you repair it, you hand over one aircraft from one station to another one. This is already state of the art. So we need a concept that's flexible enough to cater for these cases. We have to work on the regulations, of course. Initial airworthiness, we have mainly Part 21, and we need to develop several amendments for Part 21. It starts on terminology, scope, applicability, so we have to formalize the applicability of Part 21 to the unmanned aircraft and the control unit. Today we talk about aircraft in Part 21, which is generic and allows us for the moment also to certify unmanned aircraft, as unmanned aircraft are aircraft. But we need to, or we want to be more precise, especially which areas are then also applicable for unmanned aircraft, and how to best address the control unit, which is a new element. We have today a process to certify unmanned aircraft. It's an EASA policy going back to 2009, so it's a 10 years old policy, which is a policy statement on airworthiness certification of unmanned aircraft system, which provides us flexibility to identify a certification basis for an unmanned aircraft, and it's working. And with another slide, you will see that we need still some flexibility to build the certification basis for unmanned aircraft in the future. So we have to include a similar flexibility into Part 21. We have to clarify what is the type design of an unmanned aircraft and how to consider the control unit in the unmanned aircraft type design. So we have part 21A31, that's a paragraph on type design, and we have to include some elements there also to extend the concept of having a link to the operation, to the concept of operation. This is quite important to extend this in part 21. We want to introduce the possibility of an independent approval for the control unit or its components beyond the current ETSO process. We have to regulate or provide more details on reporting and airworthiness directives for unmanned aircraft systems, especially in respect to the control unit. We have to ensure that the entities being responsible for a certain area get the information they need to be able to react on unsafe conditions. Now we have an aircraft that's registered in one country. We have an operator who has his principal place of business in another country. The operator is running control units that might be in other countries, and this is adding a complexity, and we have to ensure that information is not lost in the process, so that an aircraft designer who is allowing or accepting a certain control unit to operate his aircraft receives the information when there is an unsafe condition related to this. Last but not least, we have to adapt the certificate of airworthiness to include information related to the control unit and the C2 link. In this respect, we are not exactly following the ICAO proposal to have an independent or to have a new certificate of airworthiness for an APAS, for a remotely piloted aircraft system. We want to include this information in a standard CFA and also document the approval of an unmanned aircraft in a standard TC. So we see unmanned aircraft more as a mode of operation, which might be switched between certain days or maybe even between flights or within a flight. And we want to avoid that you have to change the registration of an aircraft if you want to operate it manned on one day and unmanned on the other day. Of course, most interesting for manufacturers that now have a product and they now want to certify a product are the certification specification for unmanned aircraft system. And the first point on this slide is it's not for the immediate future. We are working on this, but we are working on an NPA, a Notice of Proposed Amendment for regulations for certified category, but new certification specification will not be part of the next deliverables for us. So we will not publish a CS for unmanned aircraft system in the next year. Nevertheless, we are working on that, and we are not working alone. We rely mainly on the work performed by JAROS, Working Group 3, and on special conditions that we develop, or we have developed, and that we continue to develop in ongoing projects. And this is also one of the justification why this is not our priority at the moment to publish something, to have concrete CS that would be mandatory for all projects in the near future. Part 21 provides us with the flexibility, and we can already now certify an unmanned aircraft system. So there is no urgent need to hurry to publish something as soon as possible. Part 21 provides us with the flexibility, and we want to take the time we need. We want to get experience in certification projects, have iterations in special conditions, and then when we are ready, we publish a CS. The illustration you see is a concept we are working on. So we call it the new landscape of CS. So you see as horizontal line the CS that we have today for different product categories. On the top, or you see the aeroplanes, CS25, CS23, CS-LSA. So these are horizontal codes for one aircraft category. Then we have sailplane CS22, we have VTOL or rotorcraft CS29, CS27, CS-VLR. We are working on a new code or a special condition for the time being for eVTOL. And we want to complement this with what we call a vertical approach. You see the vertical green line, it's a CS UAS, which should contain the requirement that are unmanned aircraft specific. And for the future, then we would compose the certification basis for a new project based on the CS that's for the main airframe, plus the relevant requirements that are related to unmanned aircraft technologies. And we have already now some other examples where we have these vertical requirements. We have requirements for propulsion systems, for engines. We have requirements for ACNS, so aircraft communication, navigation, surveillance. And so we are already now today compose the certification basis for unmanned aircraft. For example, it could be CS23 plus CS ACNS for the equipment that's required for airspace integration. JARUS is also at the moment, or JARUS is combining what was published in the past, CS LUAS into CS UAS. Yeah, and we will extract these requirements into the CS UAS, and now the new thing, and this is more or less, and also the handover to a specific category. We quite sure need to have a CS for the low end. Definitely when we want to certify an aircraft for operation in the specific category where the certification basis is mainly driven by SORA requirements for smaller thing, we want to have a dedicated set of CS, and we are also working on this for the moment in special condition. So we try to avoid aircraft configuration specific requirements. We try to be performance based, but have one code for the low end specific category, and then for the other product compose the certification basis, for example, based on CS25 plus requirements for unmanned aircraft specific items like the C2 link, like the control unit, like specific automation and recovery issues. But of course, this is something where we have to work a bit more in detail, and this also requires some changes in Part 21, as it's not only adding requirements. If you look today on requirements of CS29, CS25, they are very prescriptive, they are very detailed, they contain a lot of requirements that rely on a pilot on board of the aircraft, so we have also to remove and to modify requirements. And as we are doing it today, we use our policy. We have to integrate a similar process in Part 21. Yeah, and then hand over.
Thank you, Stefan. So I can stay here. So this is, as you see, certification of an aircraft for specific category. So one thing should be perhaps made clear. Operation in the certified category doesn't mean it's not to be confused with certified unmanned aircraft system. So to operate in the certified category of operation, you mandatorily always needs to have a certified unmanned aircraft system. To operate in the specific category of operation, you may or you may not have a certified unmanned aircraft system. And this depends on what? depends a lot on the level of risk, which we assess with the SORA, which we published as an AMC recently, the SORA, the JARUS SORA. So as you see depicted there, lower risk, medium risk, high risk. The SAIL is the specific assurance integrity level, which is a figure of risk which comes out from the development, from the application of the SORA for the operation. So for you can have a SAIL 1 and 2, which we call low risk, SAIL 3 and 4, medium risk, and SAIL 5 and 6, which is high risk. And this will lead to operational safety objectives which have an integrity in particular, which depends on the SAIL. So for the first for low risk, you see in case of standard scenarios are scenarios developed for low risk for in the specific category of operation. You have the CE class. We have this new CE mark in 5 and 6, which were not in the previous delegated act, but are in the new delegated, in the update of the annex to the delegated acts, with which we address this standard scenario that we recently published. Apart from the standard scenarios, the UAS design may be covered by the operational authorization provided by to the UAS operator by the National Aviation Authority, or alternatively, the manufacturer may apply for an RTC. This is really an alternative for the low risk. As you see, it's an alternative also for the medium risk. Actually, we see interest in this from manufacturer for this kind of application. There are some advantages. If you consider an operator which has to prove that the operation is safe according to the SORA, the operator will have to prove operational safety objectives which are related to the operator organization, are related to the procedure, to the pilot, but are related also to the design of the aircraft. And the operator may not know, of course, how to prove the design of the manufacturer, and the manufacturer itself is interested, may be interested to not provide design information to operator, but to sell already an unmanned aircraft which is ready and certified to be operated in the specific category. So what the operator will do is provide the EASA type certificate, restricted type certificate in this case, and prove the SORA requirement related to the pilot, to the operator, to the procedure. But the design will be proved by the EASA type certificate. In the high risk, it's different. In the high risk of the specific category, the certification is mandatory as per regulation, and also linked to the what is reported in the SORA as we have published it. Okay, so in the last part, you see the certified category, of course, where the RTC is mandatory. There is the approval of the operator and the licensed pilot. Can you show? Yes. So the slides actually tells you again the high-risk operation EASA type certification required with a high level of assurance and integrity. This you extract from, in particular, from the Annex E of the SORA. If you go to the design-related operational safety objective, you will extract this high level of assurance and integrity, for example, from the operational safety objectives 4 linked to design, or to the 5 linked to safety. You will need a safety analysis and compliant demonstration, which is equivalent to manned aircraft. Although, in this case, for the operation in the specific category with high risk, we may take into account limitation to the operational scenario. So there will be still some potential difference with the certification for the certified category operation, a full-fledged certification, linked to specific limitation of the operational scenario, which could lead in particular to some simplification in the IMC more than the requirement. For the medium risk of operation, SAIL 3 and SAIL 4, in this case we said that the manufacturer may ask for a voluntary EASA certification with a medium level of assurance and integrity. So here we have actually projects in EASA. We have two. I think we will have, in a short time, we will have a third one. And we are actually working on this, and Stefan said. And what we are doing is actually build a certification base which will be published as a special condition. And in order to build this certification basis for the medium risk level of the specific category, what you're looking at, of course, is the SORA, and in particular the operational safety objective of the SORA. But then we are also benchmarking with the available information for from other specification, in particular CS, UAS from JARUS. We are looking at the special condition VTOL. The comparison is sometimes interesting. And we are looking also to some certification basis issued by the FAA for lower risk operation as a further benchmarking. So subpart by subpart, we are creating this certification specification, actually the special condition, and we are doing it internally. We are interfacing with the applicants, and we will go soon through a more detailed review in EASA, the certification directorate. So some principle. It must contain a simple set of airworthiness requirements. It will be objective-oriented, as CS23 Amendment 5, as the JARUS CS-UAS, as the special condition VTOL. It will be adapted to a generic concept of operation. So it's not that if the concept of operation changes, then the CS is not, the certification base is not valid anymore. As long as certification, the CONOPS will be good for a medium risk, then that set of requirements will have to be valid. And it will refer to industry standards as AMC when available. The operator, the applicant, will have to refer to industry standard where available. When not available, the applicant may propose something else. Of course, we will have to approve all of these. And in fact, we are working on special condition and to be issued in the, I think, coming year.
Yeah, maybe I've had a first look on the question we have seen on Slido. Maybe again on Part 21, the list of Part 21 amendment. This is work in progress. And so we have published regulations for open specific category. We have the existing regulations that were drafted for manned aircraft in place, and we have an ongoing rulemaking task to amend them, to adapt them for unmanned aircraft system. So what you have seen on the slide is work in progress, and we are working on this. On the CS, the technical requirements for the aircraft, this is also ongoing and will be published in a later phase. And we rely for the moment mainly on the flexibility we have in the ongoing regulations. And one question I see here, I should be able to project what's on Slido. The second question here, Part 21 related, will the organization need to be an approved DOA, POA to be able to obtain a TC for a remotely piloted aircraft? The current Part 21 mandates a design organization for an unmanned aircraft system. We have some alleviations for recreational light manned aircraft, ELA 1, ELA 2, but this definition is limited to manned aircraft. So the current Part 21 mandates a design organization. For the future, this is on our plate for amendments of Part 21. what would be the required capability of an organization, for example, designing an unmanned aircraft for the medium level specific category. For a certified category, the answer is relatively clear. It will be a DOA, it will be a production organization. If we go to the lower level of the specific category, we have to work on a threshold how to identify when a design organization is required and what could be an alternative to demonstrate the capability for design. The first
what we could say, yes, it's interesting. We're developing on lures and in the meantime getting ready. Yeah, I would suggest until we will not publish for consultation the special condition for the medium risk. If this is what we are talking about, then you can in any case refer to the JARUS CS UAS and perhaps you can also compare with the CS special condition BTOL. In some cases, you will see the special condition BTOL. In a few cases, it's simpler than the JARUS UAS. Of course, this is for a few requirements. So you can guide according to these two elements. And the SORA, of course, take it into account, depending on what is the scope, is the certified, is the operation in the medium risk, high risk of the specific.
I asked that question.
Okay.
So we're not ready to apply for a type certificate yet. So we're mature. But on the other hand, we want to be ready, so we want to ramp up.
Mm-hmm.
But depending on what we choose to follow, maybe we overlook something, we over-design something. So
Would you be interested in operation for a type certificate which allows operation in the specific category?
Specific at first, and then even certified later, maybe. But
so depending on what you have in mind, you might have the medium risk or the high risk.
landing,
Okay.
we want to have. So I understand it's in draft, it's in work.
Yes.
We need, as you know, for economical reasons too, we only have we can only focus certain resources on certain things. We have to go in the right direction. If we find out later that, I don't know, some specific requirements.
In any case, you are not going to in the wrong direction if you take the CS lures. In any case, but consider the JARUS CS UAS and industrial standards as available, ASTM standards.
But what
as AMC to the requirement.
But what we are working on also for the special condition for a specific category, we will try to come up with performance-based high-level requirements and maybe certain requirements from CS lures or the JARUS lures could be then the means of compliance to these requirements. But what we definitely can offer is for companies that are working on projects that have to make a decision when to apply, if to apply now or later, to approach us, to contact us. We can offer also a pre-application meeting. Of course, you need to have a certain maturity, especially in the concept of operation. So this is seems to be one of the most important elements for the beginning, when to start to design and to certify or think about certification of a product for the operation in the specific category is to have a mature concept of operation, which would allow you to do the SORA, also to identify the technical requirements that you need to at the end later to convince the national authority that your aircraft is ready to be operated in accordance with the SORA for a certain sale level, for a certain concept of operation, and then we can discuss and start to communicate. And that's definitely an offer we make to all companies that want to or that are designing an unmanned aircraft. We know that the situation is not crystal clear. We cannot provide you with a cooking book, prescriptive requirements, and then you know what to do. Go through the list, and you have a perfect aircraft. That's a disadvantage. Going performance-based requirements, we stay sometimes on a quite high level, and then we postpone the discussion when we agree on the acceptable means of compliance. And the difficulty is compared to CS23, where we have a similar approach. For CS23, we have a lot of industry standards. ASTM F44 produced probably hundreds of pages. We have, I think, 20 to 30 standards on all the technical disciplines. And this is not yet available for drones. So, of course, we have when you participated the previous session on specific category, we have the AW drone project that will identify standards that should address a lot of technical concerns which are related to specific category operation. What we now try to build from our side are special conditions that would be on top of that. But of course, we might, for certain operation, identify that there's a lack of standards or that we need to add requirements, which of course might have then an impact on your design. Is the control unit the same as a ground control station in operator terminology? Probably yes. We are working on our concept for the certified category, and we have switched to the terminology control unit, and this is the terminology we currently use across all disciplines, so operation and airworthiness, continued airworthiness. So this is what we use. It's also already defined in the regulations for a specific category. So we try to stick to that terminology, and I think I can answer this as yes, it should be the same.
Part 21 is not legal for the open category. The open
yes.
for certification, the open is for buy and fly according to operational constraints and DESI marking as if you as assisted to the open category presentation. So it's not applicable there. But as we said, for the specific, when we have a certification of the UAS for operation specific, it is.
So that was a question, will Part 21 certification be needed for UAS targeted for open and specific operation instead of certified? For open, definitely not. There we have the CE marking system. For specific, it depends. If it's a standard scenario, we have also the CE marking, the CE classes there. It could also be subject to an assessment by the NAA when it's not needed to have an EASA approval. If there's a need to have an EASA approval due to the high risk, or depending on the outcome of the discussion for BVLOS urban operation, we will apply Part 21, but we are working to amend Part 21, to adapt Part 21, and also to make it suitable and more appropriate and proportionate for these type of projects. Will the certified UAS be included in the CICTT taxonomy? There I need some help. It's the abbreviation of an aircraft, which is a make model designation. This is okay. Yes, if it's a certified aircraft, we need to identify the make, model, variant, and have an abbreviation. And the main concept we have is at the end to not differentiate too much from manned and unmanned. If we want to have one TC on the same TC and manned and an unmanned aircraft, on that level the taxonomy will be the same. But of course we need to be able to identify later what is the operation. Is it possible to validate FAA type certificates for unmanned aircraft system to be used in specific or certified category? Will the DOA be necessary for the validation process? Start with a simple question first. when we have a validation project with the FAA, we follow the bilateral and the technical implementation procedures and not Part 21. So there is no need to have a design organization. We rely on the FAA process as equivalent to our design organization, or as there is no need to have a DOA, an EASA DOA. The first part, yes, it's possible to validate, and that's something we have to explore more in detail. We have not yet any validation project of a US certified drone in Europe, and we have also no project the other way around. The bilateral is including aircraft. From our point of view, unmanned aircraft are aircraft, but of course we have not yet any published CS in Europe, which is an accepted standard for unmanned aircraft. And we have, I'm not aware of any CS or part for applicable to unmanned aircraft. So when we validate, we have to agree on acceptable certification basis. The FAA, to my knowledge, is certifying drones in accordance with their Part 21 A17, which is a specific certification basis tailored to every project, which is at the end the same what we are doing for the moment. So we should have the flexibility, and as we have the same safety objectives and safety targets, we should be able to accept, with whatever amendments we find necessary, to accept the certification basis from our bilateral partners and validate a project. If a US would be an eVTOL, yes. In case an incoming product would be normally certified here. When we would validate a product where we would apply a special condition eVTOL, of course this requirement would then be discussed with the applicant and the FAA, and we have to agree on the acceptable certification basis. But yes, of course, we need a level playing field. We cannot, the requirements we apply should be equivalent to what we accept from our partners. But at the end, whatever would be the starting point for a certification basis for a similar US product, if they would start from Part 23 or Part 27, 29, or also have a similar certification basis, knowing how the FAA is working, I would expect a similar set of requirements on their side. Looking on the eVTOL, we have a new concept of enhanced category. There we might have a difference, and this, of course, then would be a subject for discussion when we accept a validation.
Perhaps I can take the last one. Will a main aircraft with type certificate still need CE marking? No. If you have a type certificate, it is to operate in the specific, either in the specific category or in the certified category operation. And there you have the EASA type certificate, and you don't need any CE marking for that. There are two separate worlds. CE marking is the market mechanism to provide a kind of airworthiness coverage for the open category through the market mechanism, and the EASA is not involved in that, if not in this phase in which we will review the standards proposed by ASD-STAN, and eventually we will supply our opinion to the European Commission about that. And of course we created the requirement, but we will not be involved in any certification of the drones for the open category.
But this is also an EASA certificate in that respect is also alleviating work with respect to CE marking. If your drone has to comply with the CE marking, it has to comply with a lot of product directives and technical requirements. And when we certify a product, even for the lowest category in the specific category, we quite sure have to ensure that we are on an equivalent standard. So we have to look into requirements that we have normally in these product requirements like REACH, like ROSE, to ensure that this type certified product is at least on a level that CE product would need to be. But that's something where we have not yet worked so much. We have no project on the Sale 1, Sale 2. And when you look into SORA, you will not find too many technical requirements that are put on products for Sale 1, Sale 2. So we will look into what we have for we might look in what we have in the open category, plus looking on some of the basic requirements we have in the SORA
sure. The
to
open
compose.
category would be also an inspiration for a possible certification basis for the Sale 1 and Sale 2, the low risk of the SORA. And again, in that case, if you get a certificate, then you don't need the CE marking for your drone. And so, if there are any other questions.
I'm not an expert on the control unit, but can it also be? Is there any requirements in terms of being it stationary, or can it also be moving? Can it also be virtual? That different roles are given to different locations or so.
So the question is related to the control unit.
Yes.
If it's one argument to use a control unit and compared to station was that it might be mobile. So it might be installed in a moving vehicle, and so yes, it could be mobile. For certified category, what is, for example, in the scope of ICAO, international IFR from aerodrome to aerodrome, a large cargo aircraft, we would expect that the control unit is protected physically and from a security point of view to a certain level, which might make it difficult to have a mobile station. We are not expecting that somebody controls with a tablet or a mobile device a large aircraft. So we expect them to be more stationary, while there still could be something installed on a ship or on something moving. Virtual is a bit difficult. We would have difficulties to identify approved design data of something that's not really existing. But of course, when we discuss or think about highly autonomous aircraft,
exactly.
the operator quite sure still needs to have systems in place, a control station, a control center, something like this, with certain interfaces to the aircraft. So the aircraft will not select its mission. There will be a process for the operator to initiate a flight, to upload a flight plan to ensure that the aircraft is airworthiness. So there will be some communication, even if it's just before the operation is starting. And this is, I think there with also the terminology of a control unit provides maybe a more flexibility and is more appropriate to something that's not really controlling the aircraft all the time, but it's something just initiating an operation.
Thanks.
Anything else?
Since we are okay.
Yeah. Thank you. Friday, 5 minutes after 5. So you really thanks for your motivation and questions, and we will keep you informed what's going on in this area. Thank you. Have a nice weekend and a good trip back home. Thank you.